Alrighty, so we're going to take a little bit of time and we're just going to review what you guys had watched yesterday. So just as a reminder, remember that when we have a sine curve, we like to look at the behavior of that sine curve. And so if I'm looking at the behavior of a sine curve, remember it starts at 0, it ends at 0, and then in the middle, it also goes to 0. So I usually like to start by plotting those points. I think that that's the best way to get an accurate graph. So starts at 0, ends at 0, and in the middle goes to 0. All right, then from there, a normal sine curve for now, in between these first two zeros, so at pi over 2, we're going to go up to a y value of 1, and then in between the second two zeros, we're going to go down to a y value of -1. Again, I like to plot those points first. I just think that it makes it a little bit easier in terms of getting a prettier graph. All right, so we're going to go up like this and down like that. Okay, and there's your sine curve. Now, keep in mind that a sine curve kind of looks like an S. It's backwards, sideways, I should say, and flipped, but it kind of looks like an S. If you kind of look at it, it sort of has this appearance of an S if we just flipped it over that x-axis and look sideways. All right, now let's take a look at the cosine curve. Cosine curve is different. Remember, the cosine curve, its behavior is to start up at its maximum and to finish also up at its maximum. And then in the middle, which would be at pi, we go down to its minimum. Okay, all right, so again, start high, finish high. In the middle, go down to its minimum. Now, in between the max and the min here, therefore at pi over 2, we're going to be hitting the x-axis, and the same thing here. So at 3 pi over 2, we're going to be hitting the x-axis. So let me put dots there as well. I always like to plot the points first. It'll make your picture look a lot more accurate. Now remember, the cosine curve has to flare, so it's going to look like that. And there's your cosine curve. Now, remember how I said that the sine curve kind of looks like a sideways flipped S? Well, if you look at the cosine curve, it looks kind of like a C on its side. Okay, so now if you would turn to page 3, let's just look for a moment. And on page 2, the explanation of all of this was given, but it says up here, what effect does the value A have on the graph? Notice that the A is coming before the word sine, or it comes before the word cosine. A is your amplitude, and it says right here, a number in front of the sine and the cosine changes the amplitude. Amplitude is just a fancy word for height. So when you see that word amplitude, all you're going to do is think the height of something. Okay? All right, so now, if we look at the first graph here, we notice that the amplitude is 2. So here, if we look at this normal sine curve, right, the amplitude is 1. That's the distance from what we'll call the midline, in other words, the middle of the graph, to the maximum, or from the middle of the graph down to the minimum. That's its height or its amplitude. And this is a distance of 1, so this one's just going to be a distance of 2. So just like in any other sine curve, remember a sine curve, the behavior of the sine curve is it starts at 0, it finishes at 0, and it goes to 0 in the middle. All right, now, instead of the amplitude being 1, the amplitude here is going to be 2. So look at what I'm doing to my y-axis. Make sure you're putting this in your notes as well. Okay, so at pi over 2, instead of being at 1, I'm going to be at 2. And then at 3 pi over 2, instead of being at -1, I'm going to be at -2. So the only thing that's going to happen is this graph is going to be stretched out more vertically, so to speak. Okay, and there's your graph of y equals 2 sine x. All right, I'm going to go to the one below it. So the one here that says y equals negative sine x. Well, this is the same exact thing as this. The only difference is we have a negative here. So take a guess, what's going to happen to this if there's a negative in front of this? This is a -1. This amplitude is a +1. So all it's going to do is take this graph and flip it. So again, remember any sine curve starts at 0, ends at 0, and goes to 0 in the middle. But here's going to be the difference. The difference is that our amplitude is still 1, but we're going to go in the negative direction. So pi over 2, instead of going up 1, we're going to go down 1. And at 3 pi over 2, instead of going down 1, we're going to go up 1. So it's going to flip like that. And there's your y equals negative sine x. Okay, now again, let me rephrase. This amplitude, the distance from the midline to the maximum is still 1, and the midline to the minimum is still 1. So the amplitude is still 1. This negative just tells you what direction to go in first. So just a reminder, amplitude can never, ever, ever be a negative number. It always has to be a positive number. But this negative, again, just will tell you what direction you're going in. In this case, from the sine curve, after 0, where are we going? Are we going up or are we going down? Okay, so let's look at the next one over here in the top right. So we see that the amplitude is a half, and it's a cosine curve. Okay, so let's do a couple things here. So we know that this would be 1, this would be 2, so this would be -1, and this would be -2. Okay, now, remember a cosine curve. It usually starts up at its maximum and finishes up at its maximum, but be careful because its maximum over here is 1, but here its maximum height is going to be at 1/2. So let's make sure that we are at 1/2. We finish at 1/2. And then remember, in the middle, which is at pi, okay, let me just go back here. At pi, we go down to its minimum, which is -1. Here, our minimum is going to be -1/2. So at pi, we're going to be at -1/2, which is right there. So make sure that you're writing this into your notes packet. All right, so there it is. And then, just like usual, at pi over 2, we're going to hit the x-axis. And at 3 pi over 2, we're going to hit the x-axis. And make sure you flare this. So do you see how it kind of, it's a lot flatter because its amplitude is only a half. Okay, so here, your amplitude is 1/2. Here in this first one, your amplitude is 2. And here on this other one, the second one here, your amplitude is 1. Remember, amplitude will never ever be a negative number. It's like an absolute value. All right, so let's look at the last one. So then the amplitude on the last one is also going to be 2. Again, not negative. So let's adjust our y-axis. So we go up to 2. We go down to 2. And remember, a cosine curve starts at its highest point, finishes at its highest point, and in the middle goes down to its minimum. However, look at this. This negative, like the negative over here, flipped our graph. So this graph here is going to get flipped. So instead of starting high and finishing high, we're going to start low and finish low. All right, so we're going to start low at, oops, let me put my marker back on. We're going to start low at -2, and we're going to finish low at -2, which then means at pi, we're going up to +2. We're still going to hit the x-axis at pi over 2 and 3 pi over 2. And just make sure you flare, but we're flaring kind of in reverse here. There you go. So that is y equals -2 cosine x. All right, now turn to page 4. If you look on page 4, it says, what effect does the value b have on the graph? Notice the b is the number that comes after the word sine or cosine. A is the amplitude, that's the number that comes before the sine or the cosine, and b is what we call the frequency, and that comes after the word sine or cosine. So I wrote the definition up here of what frequency is, which was on a previous page. But B stands for the number of curves that you're going to see from 0 to 2 pi. Okay, so in reference to this first question down here, this says y equals sine 2x. So notice that that number comes after the word sine. So what this means is we're going to have two curves. Here we go. Two curves from 0 to 2 pi. So let's just go up and look at this curve right here. Normally, this is one curve. A sine curve is an up and a down. That's one curve. A lot of kids mistakenly think, oh, this is one curve and this is another. This is one sine curve. Sine curve has to have that full S. Okay? So we need two of these squished in from 0 to 2 pi. So if normally one curve starts at 0 and ends at 2 pi, we have to get two curves that will start, the first one will start at 0 and the second one will end at 2 pi. So then ask yourself, well, if one curve is normally from 0 to 2 pi, and I need to get two of them in there, when will my first curve end? And hopefully you'll say, oh, hold on, I need one sine curve from here to here, and then the second sine curve from here to here. You see that will give me two curves. Here's the first one, and here's the second one. Okay, so here's how we're going to do it. We're going to go based upon the behavior of the curve. So a sine curve, remember, normally starts at 0, and my first curve has to end here at pi. There's the end of my first curve, which means the middle also has to hit 0, right? So that's going to be right there. Okay, now, in between these two guys right here, remember I'm supposed to go up to my max, and in between these two guys here, I go down to my minimum. All right, so I'm going to go to the middle, and that's going to be 1.5 boxes in, and there I go. So you got to go. Please make sure that you're going directly in the middle here. There's 1, 2, 3 boxes here, so I'm going to the middle of that, which is 1.5, and going up. The same thing here. There's 3 boxes here. I'm going to the middle, and I'm going to go down, and I'm going to put a dot here. Okay, so make sure you're putting this also in your notes. Okay, so just to show you, there is your first curve. Now, we need two curves from 0 to 2 pi, so we're going to repeat it. Here's the beginning of the second curve. Here's the end of the second curve. Here's the middle of the second curve. Again, in the middle of that, go up to 1. And in the middle of the next 2 dots, go down to -1. So, okay, there you go. So you can see we have one curve and then 2 curves. And that's 2 curves from 0 to 2 pi. Done. Okay. All right, let's look at the one below it. So this is y equals sine 1/2 x. So this means just a half a curve from 0 to 2 pi. Let's go back to this original one. This is a full curve here. So a half a curve would just be from here to here. That's a half a curve. And that half a curve, this top part, is what we're going to see from 0 to 2 pi. Okay. So we know that the amplitude is 1, so I'm just going to put a 1 here, because remember the number in front determines how high we're going. So we're going to start here, and we're going to finish here. Now, those 2 dots, just to reiterate, is this dot right here and this dot right here. So then let's backtrack a second. So in the middle, we go up to its amplitude, or its highest point, right? So I'm going to go middle, highest point, and you're going to put a dot right there. Okay. So there we go. And it's stretched out, but it's supposed to be. And there's y equals sine 1/2 x. Okay. Now, let's look at y equals cosine 2x. Same principle as what we did with y equals sine 2x. You're going to have 2 cosine curves from 0 to 2 pi. So if a normal sine curve takes all the way to 2 pi to finish it, we're going to have 2 of them from 0 to 2 pi. So the first one's got to end right here at pi, and then the second one will be here. Okay? All right, so let's start with our amplitude, which we know is 1. So let's just put a 1 here and a -1 here. Now remember, a cosine curve, its behavior, we start up and we finish up. And then in the middle, we go down to the minimum. Okay? This is where I want you to be careful. We have in here, in the middle here of this interval, is where we're hitting the x-axis. So go 1.5 boxes, put a dot, and then here, go 1.5 boxes and put a dot. Don't do it anywhere else besides 1.5. Exactly. Okay, you're going to get points taken off if you do. All right, so there is your first cosine curve. Now we're going to repeat it. So here is the start of my second curve. Here is the end of my second curve. At 3 pi over 2, you go down to its minimum. Smack dab in the middle, we'll have a 0. Smack dab in the middle, we have a 0. And there is your second curve. And that's y equals cosine 2x. All right, last one. Y equals cosine 1/2 x. So we're going to have a half of a cosine curve. Let's go up here and let's look at this cosine curve. This is a full cosine curve. So a half would start here at its maximum and go down to its minimum. And you're going to see just that part from 0 to 2 pi. So it starts at its maximum. Okay? Starts at its maximum. And then it finishes at its minimum. Just like that. All right, now let's go back. So what we just drew was this starting point and this finishing point. Now don't forget, smack dab in the middle, we should be hitting the x-axis. Well, if this is at 2 pi and this is at 0, the middle is at pi. Okay, so at pi, you're going to put a dot. Now, just be really careful. A lot of kids like to just kind of draw a straight line. Look at the behavior of this graph. Flares and then flares in. Okay, flares out, flares in. So make sure you mimic that. So you're going to kind of go flare out, flare in, like that. And that's what your graph should look like. Okay, please do me a favor. Make sure that you're getting all of these notes in your packet.